All right, here we have a refraction problem. We got a beam of light coming in from the air to a block of ice. The block of ice is in its refraction of 1.31, so that's what we'll be hitting. The beam of light is coming in at this side at 70 degrees from the normal. And we want to know what angle it exits at. Okay, that means we've got to do a two-step problem here. We're not just talking about it going into the block, we're talking about going in and then it's going to come out. All right, so let's draw how it's going to look. We know that it's going from a lower index to a higher index, which means it's going to bend towards the normal. Okay? So actually let's draw this a little bit more exaggerated here. Coming in, 70 degrees. It's going to bend towards the normal. So it's going to be a little bit at an angle like that. Okay? It's then going to hit the other side. And now it's going from a high to low, which means it's going to bend away from the normal. Now the normal is now horizontal instead of vertical because it's hitting a different side. And we're going to have it bend like this. Let's make it a little more exaggerated there also. Okay? So the question is, how is that bending going to occur? All right, well we know Snell's law governs refraction. So let's look at the first barrier it hits. Okay, we've got N1 sine theta 1 equals N2 sine theta 2. N1 is 1, so that's air. Sine of 70 degrees equals N2, which is going to be 1.31 times sine of theta. We do this, we should get that theta is equal to 46 degrees. So we know that this right here is 46 degrees. Okay? Now, the question is, how does that relate to our second one? We're not done. How do these two connected? And the answer is that here we need to know this angle right there. All right, but that 46 is not that angle. So now we got to do a little bit of right angle work. Okay? We know that if this is 46, this is 44. And if that's 44, this is also 46. Yes. And if that's 46, then this is 44. Okay, again, all that's being done by knowing that right angles add up to 90, and that is a right angle triangle, so the other two angles add up to 90. So now we know it's 44, so the angle of incidence is 44. So we're looking at our second one. We have, again, N1, which in this case is 1.31 because it's coming from the ice now, times sine of 44, and that's equal to N2, which is 1 this time, times sine of theta. And we call it that theta is equal to 66 or so degrees. And that is this angle right here. And that is a refraction problem. Awesome.